Well, good morning, good afternoon. Thank you all for joining us today. Thanks for tuning in. For this edition of our Customer Spotlight, I'm pleased to welcome leading cloud-based content and document management system, NetDocuments. My name is Ruben Rosado. I'm an account manager here at Couchbase. I've had the pleasure of working with their amazing team over the past year, and leading that team is our presenter today, Jordan Gillespie, who is the Director of Platform Engineering at NetDocuments, and he'll be walking us through their journey with Couchbase. At the end of his presentation, we will have time for a Q&A, so please feel free to put any questions you have down in our chat box. We'll make sure to answer all your questions. Good morning, Jordan.
Good morning, Ruben. Thanks for the introduction.
Thank you. The floor is yours.
Okay, awesome. So once again, I'm Jordan Gillespie. Thanks everyone for attending today. A little bit about me and history about NetDocuments a little bit. Before we get started. So I'm Director of Platform Engineering. I've been at NetDocuments about 8 years. I'm responsible for our automation, site reliability engineering, and performance and analytics engineers. Those teams all report to me. And so most of the, how the application runs on our infrastructure is my team's responsibility. A little bit about NetDocuments. NetDocuments have been around since about 1999. We are the leading legal document management system, cloud-based document management system for the legal industry. We provide document management for law firms, anywhere from single attorney, small law firms, all the way up to some of the largest law firms in the world, plus a lot of corporate legal uses NetDocuments for their document management system to be able to share and store and secure and organize their documents, contracts, legal briefs, that type of thing, and those are all stored in our platform. We have data centers that we operate globally, primarily in the US, the UK, Germany, and Australia. We've also just opened a new offering for government US, and that's in Azure government. And so we've got a lot of experience operating large scale systems over the last 21 years. And so that's a little bit about NetDocuments. So our use of Couchbase, we have about, we started out using Couchbase Community Edition several years ago. We've grown our use of Couchbase Community Edition. We have over 100 nodes globally of Couchbase Community Edition. We've been an enterprise customer for about 2 years and have approximately 120 enterprise nodes of various sizes. And we'll talk a little bit about those as we get into some of the use cases. So today I wanted to cover 3 primary use cases that we have for Couchbase. And I'll go into each one of those: our directory use case, our SQL replacement use case, and our NAS device use case. And then I'll wrap up with some lessons that we've learned as we've implemented some of these use cases, and then we'll go dive right into questions. So first off, our directory use case. So at NetDocuments, we use a directory, which is basically just a compilation of users and their relationships to the groups that they're in and the kind of organizational attributes about groups of documents. So a repository, a cabinet, all of the relationships between a repository and a cabinet, the users and groups, and which repositories and which cabinets those things belong to and have membership of. And so all of that organization is stored in a directory. And the legacy solution that we had for that was a product from Novell, which was developed in 1993 called eDirectory. And because, as you can imagine, it was developed in 1993, it has some legacy features about it. Replication lag, for one. So when you did a write to eDirectory, it was replicated to other nodes of the eDirectory kind of cluster. Not really a cluster, but that write, the lag between it getting written to one node and then that replication to other nodes in the cluster was measured in minutes, not in seconds, and certainly not sub-second. And so that was one of the hard things about that. And so one of the results of that replication lag was that if you wrote to one node in the cluster an object and then you wrote to another node in the cluster that same object, when those went to replicate, they would have collisions. And that was something we dealt with very often. And so in order to combat the collisions, we would send all of our writes to one single server, which caused us to have to hugely vertically scale that single server. Plus, eDirectory is a product that is dying in its support from the various companies that own that product these days. And so we had to find a new solution. And so we the solution that we came across for this was obviously Couchbase. It was apparently clear that Couchbase was the correct solution to implement our directory, and so we did, and we are running. We successfully migrated all of that data to a cluster of Couchbase nodes, enterprise Couchbase nodes. This is a pretty interesting use case for Couchbase. There's only about 4 gigabytes of data in this directory cluster, but the query rate, as you can see, about 300 nickel queries per second on our biggest one of these clusters. That's pretty high for nickel queries, and so we ended up using multi-dimensional scaling, which is a feature of Enterprise Edition, to be able to have more query nodes than we actually have data nodes. I think in the biggest cluster here, we have 5 or 6, or maybe even more than that, query nodes with only 3 data nodes, because we just did the minimum number of data nodes because we're only talking about 4 gigabytes of actual data. And so it made a lot of sense to do memory optimized indexes for this cluster, because that's, it's heavy nickel query. There's a little bit of key value access too, a fair amount, but it's mostly nickel that we use to access these. Because of the nature of that data, you think about the relationship between users, groups, their membership, that's all very relational, and nickel then makes a lot of sense to be able to access that data. And so we ended up deploying that on smaller VMs and scaled that to meet the workload. And anytime that we're coming up on, it's really easy to monitor this with watching the CPU usage on the query nodes. If we have alerts around that, if we get to a sustained CPU usage of about 80% on any query node, our solution is just to add more query nodes. And we've done that once or twice, and it's worked out really, really well. I know this solution will scale for our needs down the road as we grow our customer base. So that's the first use case. The next use case I want to talk about is a SQL Server use case, where we've migrated some data out of SQL Server into Couchbase. So to explain a little bit about what we were doing with SQL, I'll start there. So we had a SQL table that has a row in it for every single document in our system. And so that row is a mapping of the document ID to its location of its metadata on disk. And so that mapping is pretty straightforward. It's a key and a value. And so the key was apparent that it would be the document ID, and the mapping, the location on disk would be the value. And so Couchbase made perfect sense to be the solution there. And so, as you can imagine, with as many customers and documents that we have, this Microsoft SQL table, it was approaching 3 billion rows. And that, a single table with 3 billion rows has its problems, right? It's hard to do index maintenance. We ended up having to hugely vertical scale that SQL Server database. We were on SQL Server 2008 R2, and so we didn't have any of the modern SQL features of always on availability groups and things like that. And we found that it would be cost prohibitive to move to SQL Server 2019 or whatever it is that's out these days, because it just didn't make sense from a cost perspective. And this SQL Server, from an architecture perspective, it just didn't make sense to have 3 billion rows in a single table anymore. And so Couchbase was the obvious solution to that as well. And so we implemented Couchbase to run this use case, and ended up running it on small, kind of scale out 1U physical servers. They're kind of commodity, easy to replace. This data is mostly key value access, as I kind of described before. There's billions of rows, and we like to keep a lot of it in memory, because the kind of not query, but the access rate across the data set is is pretty substantial. We don't have to have 100% of it in memory. We end up running with about 50 to 40 to 50% of it in memory at any given time. And so Couchbase was an obvious solution there again, because you don't have to keep all of it in memory all at once. And we implemented this with rack-aware server groups, and so the availability is really high on this, and the replication to the DR site is instant with XDCR, and we really like this solution. It's a good solution, and it's scalable for the future, and we're very happy with the performance and the scale that we're getting out of moving the docs table from SQL Server to Couchbase. So the last use case I want to talk about is something that we actually haven't implemented yet. We're in the planning phase of. This is our NAS Device Use Case. So real quickly, just to understand a little bit more about how NetDocuments works, there are files that we store on a NetApp device that are JSON files. Those JSON files are the actual metadata files of the document. So if we go back to our SQL Server use case, we have the document ID. That document ID maps to a metadata file on disk. This metadata file on disk is one of these JSON objects, and there's at least 2 JSON objects for every document in the system. So that's billions of JSON files that we store in millions of directories on a NetApp, and so that we're basically treating a NetApp like a NoSQL database, and so clearly the next step is to actually implement it on a NoSQL database, not on a NAS. But when NetDocuments started 21 years ago, NoSQL was not something that anybody had ever even dreamed of at that point, and so it made sense and was the right tool at the time. But now that legacy solution is coming up on its end of life, and so we're going to implement Couchbase to solve this problem. One of the problems with using a NetApp like this is NetApp replication to the DR site. While SnapMirror is very good, it's scheduled in time intervals, 5 minutes or 10 minutes, and so it's definitely not sub-second replication like XDCR is. And it's another huge vertical scaling point in our infrastructure, and we want to get rid of these vertical scaling points, and we want to move to horizontal scaling in every place that it makes sense. And we've got most of these vertical scaling points out of our infrastructure at this point, and so this is kind of one of those last things that scales vertically, and Couchbase is another horizontal solution that makes a lot of sense here. So the kind of the future and the plan with this solution is that this is actually a very large data greater than memory use case. There's only about 1% of these JSON files that are active at any one given time, and so it's a very good use case for Couchbase, because Couchbase does an excellent job of only keeping in memory the things that are active, and it lets it, if memory's filled up, then it keeps the active stuff in memory, but lets the older stuff go to disk, and so that's a good solution here. On NetApp, it's all on spinning disk. In Couchbase, it's going to go to solid state disks with the active stuff in memory. So I think we're going to see a performance boost. And some of our initial testing in some of our newer sites has shown that there is a performance boost here. So I'm actually really looking forward to the conversion to get off of the NetApp for these small JSON files and actually use a NoSQL database, because that opens up a lot of possibilities in the future too, for being able to leverage maybe some full text search or some nickel queries. Although initially this solution will only be key value, because that's kind of how it is today on the NetApp device. It's very difficult to query across a file system, if not impossible, especially when we're talking about billions of files. But once we get this data moved into Couchbase, that opens the door for a potential to be able to do some searching across that data set. Although we also have a dedicated search engine on Solar, and so we'll have to see how that all works out. So those are the 3 use cases that I wanted to discuss today. Now I'll get into a little bit of some of the lessons that we've learned as we've implemented these solutions. So the first kind of big lesson that I've learned personally, that if you would have asked me before we started implementing Couchbase, I maybe would have given you a different answer to this problem. So this is tune the cluster to the workload. So sometimes it makes sense to have a small cluster of VMs for a particular workload. Sometimes it makes sense to do things on bare metal. Sometimes it makes sense to do things on big bare metal. And I think that's something that you know, sometimes it intuitively, it would make sense to put all of your Couchbase data into a single Couchbase cluster, because Couchbase is really good at handling that. But for us, it made a lot of sense to separate out some of the disparate workloads. And we were able to leverage multidimensional scaling and put the resources where we needed them. In the directory use case, we needed a lot of query nodes, and that, you know, that works out really well. But on our SQL use case, we don't need a lot of query nodes. It has a little bit of nickel query, but it only has two query nodes, and so it doesn't, you know, and those query nodes are, there's the only reason that there's two is just to get the redundancy. Those are very underutilized, but there's a lot of key value access on that cluster, and so the data nodes are bigger and under a lot more load. You know, memory optimized indexes versus plasma indexes, that's a cluster-wide setting, and so if you have to use memory optimized indexes like we did with our like we wanted to do with our directory data, to have those indexes in memory at all times, knowing that they're not very big indexes because the data set's not very big, but we wanted to get the performance boost of having those in memory at all times. So that made a lot of sense. Where sometimes, you know, with the directory data or with the SQL data, for example, it has an index or two that are important indexes, but they don't have to be in memory at all times. And so plasma indexes would be perfect there. And so that, you know, based on the nickel requirements and index size, it helps to be able to tune the cluster to the workload. That's something that I've learned over the last couple of years, is that understanding the use case and understanding the architecture helps to tune the cluster to the workload. The next thing is VMs versus hardware. You know, when we first set out to start implementing Couchbase, it was hardware all the way, right? We wanted to make sure that we had the performance of that hardware brings, the, you know, dedicated CPU cycles, and sometimes that's great. And with some workloads, that's exactly what you need. But we found out that on small data sets with different workload requirements, VMs are perfectly adequate to service the workload. And so that actually helps when talking about doing stuff in the public cloud, that you know, virtual machines make a lot of sense. And so that's a lesson that I learned as well. And a couple of years ago, I was, you know, hardware all the way, but now I've come to find that VMs are perfectly adequate, and that VMs can do this job if the VMs are sized appropriately and tuned for the workload. Another lesson we've learned is to split up disparate load patterns. This kind of goes back to the tune the cluster to the workload, but where applicable, disparate load patterns deserve disparate kind of scale patterns. And so if you have for example, for us, the directory, the docs table, and the NAS data, those don't belong on the same cluster together. Intuitively, yeah, you could probably put them all on the same cluster together and use an index that's, you know, type equals directory, type equals docs, type equals data, or something like that, and that would probably function. But I think we get better scale, and we're able to put the scale where the load is more effectively because we've split up that load into different clusters. And there's different index requirements. Like I mentioned before, memory optimized indexes is a cluster-wide setting, and so some workloads require MOI, and some would be fine with Plasma. And so that's kind of a good lesson that we've learned here. And then another kind of really good, just general best practice that we've learned over the last couple of years working with our engineers and deploying Couchbase solutions is to scope the workload requirements during the design phase, not after the solution is in prod, right? It's helpful to ask questions like, does this implementation favor key value, or does it favor nickel? And it's important to ask that question at design and architecture phase, not after we've already got it deployed and running in prod, because, you know, obviously it's too late at that point. Will there be full text search, analytics, eventing, et cetera? Because that helps to design the cluster and design how you want to deploy into production. If if the workload isn't going to require any of those things, well, then you don't have to worry about designing for it. But if it does, then you can take that into account when designing it. So those are some of the lessons that we've learned as we've implemented Couchbase. You know, the future's bright with Couchbase. I'm really excited to see what we do in the future. We've got some other use cases coming in the future where we'll continue to displace SQL Server, where we'll continue to kind of change our architecture to be more modern and more scalable. And I'm excited for the things that we can do as we've kind of understood how to deploy Couchbase and how to operate and run Couchbase and have a center of excellence for Couchbase. That's been really great. So thank you very much for attending today.